Hello, myself Dr. Vijay Chandra Jaidla welcomes you to today's session on cloud computing. As part of cloud computing series today I am going to discuss regarding the deployment models. Cloud computing is an ambiguous, convenient, on-demand network access to a shared pool of configurable computing resources. Example, networks, servers, storage applications, and services. This cloud consists of four deployment models that are private cloud, public cloud, community cloud, and hybrid cloud. As part of cloud computing series, Unit 1, Cloud Computing Introduction, the lesson 3, that is the different concepts which we are going to discuss here are cloud computing deployment models, well-architected framework, design principles for cloud applications, cloud security, shared responsibility model. Myself, Dr. Vijay Chandra Jaidla, Associate Professor, Department of Computer Science and Artificial Intelligence, School of Computer Science and Artificial Intelligence, SR University. In this particular session, I am going to discuss related to the cloud deployment models as well as well-architected frameworks, then design principles with security and shared responsibility model. First, related to the private cloud. In the cloud infrastructure, it is provisioned for exclusive use of a single organization, compromising, that means allowing multiple customers of that particular organization or related business units. This private cloud indicates related to the one particular single organization. It may be owned, managed, and operated by the organization, a third party, or some combination of them, and it exists on or off premises. So the cloud computing deployment model, the first model is the private cloud where it relates to a one particular organization. To discuss once again, private cloud, the cloud infrastructure is provided for exclusive use by single organization comprising multiple customers or consumers, example business units. It may be owned, managed, and operated by the organization, a third party, or some combination of them, and it may exist on or off premises. So, this is all about the private cloud. Then comes to the community cloud. The community cloud is the provision for exclusive use by a specific community of consumers from an organization that have shared concerns such as security requirements, policies, missions, and compliance considerations. So these are the shared concerns among the different organizations of the same community. It may owned, managed, and operated by one or more of the organizations in the community, a third party or combination of them, and it may exist on or off premises. So here the cloud community related to the cloud deployment model, a community will associately share the resources of the cloud. So the community deployment model of the cloud is considered as the cloud infrastructure that is provisioned for exclusive use by specific community of consumers from organizations that have shared the concerns such as security, mission, policy requirements, compliance considerations, and it is owned and managed and operated by one or more organizations which coordinated as one community and or a third party or some combination of them, and it exists on or off premises. This is all about the community cloud. The first cloud we discussed is the public cloud. Then we discussed about the community cloud. Public cloud is you meant for only single organization. Community cloud is meant for a group of organizations. Now related to the public cloud, the cloud infrastructure is provisioned for open use by general public. It may be owned, managed and operated by business, academic or government organization or some combination of them. It exists on the premises of cloud provider. Then comes to the hybrid cloud. So the public cloud where it is open access for everyone related to the general public, that is for a business, it may be for a business or it may be for an academic purpose, that may be, or it may be for a government organization which is open for general public is considered as a public cloud. The cloud infrastructure is provisioned for open use by the general public. It may be owned, managed and operated by a business, academic or government organization or some combination of them. It exists on the premises of cloud provider. So these are the different clouds which we discussed till now. One is the private cloud, community cloud and public cloud, and finally related to the hybrid cloud. The cloud infrastructure is a composition of two or more distinct cloud infrastructures, that is private, community or public, that remain unique entities but are bound together by the standard or proprietary technology that enable data applications probability, the cloud bursting for the load balancing between clouds. So here the hybrid cloud is the combination of either a public and community or public or private or any combination of private, community or public. So here the combination of different deployment models of the cloud is considered as an hybrid cloud, where all the good qualities or the advantages related to the hybrid cloud is all the good qualities or characteristics are combined for the sake of the hybrid cloud. So the hybrid cloud, the cloud infrastructure, it is a composition of two or more distinct cloud infrastructures such as private cloud, community cloud or public cloud that remain unique entities, but they are bound together for the standard or proprietary technology which enables data and applications probability. So here this public cloud is meant for the data and applications which enables a particular purpose, and this will be in combination of other three deployment models, that is private, community and public. By this we discussed related to the four deployment models, that is public deployment model, private deployment model, community deployment model and hybrid deployment model. Now we are going to discuss related to the well-architected framework. We are going to discuss different pillars associated with the well-architected framework. The different pillars associated with the well-architected framework are operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. Well-architected framework is a set of best practices and guidelines designed to help organizations build secure, high performance, resilient, efficient and cost effective systems in the cloud computing environment. It provides a consistent approach of evaluating the cloud architecture, designs and identify the areas for the improvement. So the well-architected framework is for the guidance and for the set a best practice for the organizations to build secure, high resilience, high performance, efficient and cost effective system. While the concept of well architected framework is general practice applicable in cloud computing, it is the most efficient and prominent structure associated with the cloud providers, and it offers its own version, that is AWS well architected framework. Amazon Web Services is providing a well architected framework which is having the different pillars associated to it. The first one is the operation excellence, which runs and monitors the systems, community, and improve the process and procedures. Related to the security, it will protect the system information, systems, assets, and data security is the major challenge here, and this will be one of the major pillar for the cloud computing of AWS. Then reliability means we can depend on it confidently. When we depend on a particular system confidently means if it works without any error, it ensures a workload and it performs intended functions, that is correctly and consistently, and can recover from failures. Then comes to the performance efficiency. It uses the computing resources effectively, efficiently to meet your system requirements and maintain the efficiency as need for the service and as need for the performance of the well architected framework for the sake of efficiency. Next comes to the cost optimization. It will avoid unnecessary costs. It will minimize the business values that needs the cloud to be invested. Then sustainability, minimizing the environmental impacts of running the cloud workloads. It makes one of the character or the pillar is sustainability. Then comes to the focus, operational excellence pillar. The operational excellence pillar majorly focuses on run and monitor systems to deliver business values. It also focuses on continuously improvement supporting system based on the different procedures and processes. It has the policy to make the deliver business value with key topics such as automating changes, responding to the events, defining the standard to make daily operations. So here operational excellence pillar majorly focuses on monitoring the systems to deliver the business value, and concurrently, continuously, it will improve the supporting process as well as the procedures. It also takes the keynotes or key topics, that is automatic changing, responding to the events, defining the standards to manage daily operations. Next comes to the different design principles of operating excellence pillar, that is deliver business values related to the operational excellence pillar. The design principles are to perform operation as code, different operations as code, and make frequent small reversible changes, and it will refine the operational procedures frequently. It anticipates failures. It will learn from all operational failures, that is Updation will be continuous process related to the AWS. Then comes to the, it will use the managed services. It will implement observability for operational insights. So the operational excellence pillar has different design principles where it will identify the errors and it will update itself so that automatically updation will be done so that there won't be any type of operational failures. Next comes to the another pillar, most important is the security, which focuses to protect the information system and it assets delivering the business values through risk assessments and mitigation strategies. So security is the major pillar which will protect and monitor the systems, and key topics here are protecting confidentiality and integrity of the data and identifying and management what do you want. That is, here it is using the major principle of cloud security principle, that is CIA, confidentiality, integrity and identity and authentication, and as well as the other principles such as authentication, authorization and accounting. So here the major principles such as confidentiality, integrity, identity, authentication, authorization, auditing, and managing the system requirements for the protecting the systems and enabling as well as establishing the controls to direct security events. So these all are considered as the security pillar. Next comes to the security design principles that will protect and monitor the particular system. So here the security design principles majorly implement strong identity foundation. That means only the authenticated persons can use the system as per their authorization credentials. Next comes to the enable traceability, that is accounting. Every activity in cloud will be accounted and audited. So here it will enables the traceability, that means where, what happened at what time, and the footsteps will be identified. Next, apply security to all layers. Then automate security best practices. Protect data in transit and at rest. It will protect the data in the transit as well as at rest. Keep people away from the data. That means personal security, physical security. Then comes to the prepare for security events. So in an organization, there should be an awareness related to the security. So these are the different design principles related to the security. Then the next pillar is reliability. Reliability means we can depend on it confidently. When you can depend on the particular system confidently, the failure rate is, if the failure rate is very less, and if it fails also it is able to recover by itself automatically, then only we can depend on the particular system confidently. So here the reliability pillar major contribution is it will recover from failure and mitigate disruption. So here it will majorly focuses on enabling the work performance. It intended function correctly and consistently when it is expected to do it. Then comes to the key topics, that is designing distributed systems, recovering and recovery planning. That means when there will be some type of the failure, then there will be a recovery plan so that there won't be any disturbance in the particular system. Failure will be recovered and mitigate disruption will be avoided. Then the final thing is handling the change. So this is the major pillar related to the reliability. After the reliability, the next concept is related to the design principles of the reliability pillar. That is, reliability failure may be avoided based on the design principles, that is automatically recover and failure from failure. if any chances there is a chances of failure, that automatic recovery system will take care of the automatically regarding this. So it is automatically recovery from the failure. Then test recovery procedures. Then scale the horizontal to increase the aggregate workload availability. Then stop guessing capacity. So no need of how many people will has to work on this particular system. As it has the scalability as per the requirement, automatically it will scale and it will won't make the server to be down. Then comes to the manage changes in automation. So automatically this will be taken care. So we can confidently depend on the AWS cloud environment. That's why one of the well architected framework is reliability pillar. Then after this, the next pillar is performance efficiency pillar. So the calculation of the performance. Resources will be identified and the monitoring system will be there related to the cloud environment. So this is also one of the pillars of the cloud well architected framework, that is performance efficiency pillar. So here the use IT and computing resources effectively to meet the system requirements and to maintain that efficiency as the demand changes and technology involved. So based on the technology involvement, this particular performance efficiency pillar will work. The key topics related to the performance efficiency pillar are selecting the right resource types and sizes based on the workload requirements. Based on the requirements, the resources will be identified and the sizes will be based on the workload requirements. Then comes to the monitoring performance, then makes informed decisions to maintain efficiency or business need as it further involvement. So these all of the performance efficiency pillar where it focused as well as the key topics which are involved. Then comes to the performance efficiency design principle. There are majorly 5 design principles related to the performance efficiency design principles. One is democratize the advanced technology. So it will adopt the advanced technologies as per the requirement and it will go in global in minutes, since all the servers are not at one place. All over the world these servers are attached and it will be communicated with each other. And even it provides a well architected framework. It will use the serverless architectures and where the experiment will be more often easier and performance will be with heavy high performance capacity, and it will even consider the mechanical sympathy. Next comes to the cost optimization principle, which is the major principle where you are going to avoid the unnecessary costs. So here you are going to understand how to control the money in which you are going to spend. So the CloudWatch as well as cloud monitoring system will help the user to control or avoid the unnecessary costs. Then it will select appropriate right number of resource types. Since there are so many resources in cloud, as per the user requirement, he can use the resources where he can analyze the spend over time and he can scale the meeting business which needs without overspending. Then comes to the what are the different cost optimization design principles. The cost optimization design principles related to the well architected framework is how this particular cost optimization principle eliminate the unneeded expenses, that is implement the cloud financial management, adopt a consumption model, and it will manage the overall efficiency. It will stop spending money on undifferentiated heavy lifting. It will analyze and attribute the expenditure. So these are all the different principles related to the cost optimization design principle. Then what is the well architected framework? So the architecture of the cloud is the art of how you are going to design Here in the diagram, here this one is related to the structure design where it will drawn with the some scale or some pen and on paper. But you can see the complete structure which is constructed. So there is a much difference between designing a structure and constructing a structure. So a structure or architecture is the art of science and arts of the designing and building large structures. Their large systems require architectures to manage and their size and complexity. Now comes to the cloud architectures. Here it will be collaborated with the design makers to pinpoint business goals and identify areas for compatibility enhancement. It makes ensure a solution technology which can deliverable directly support business goals, and it collaborate with the delivery teams to ensure the technology failures of the solution are appropriate. So here this is all about the cloud architecture. So what we discussed is related to the well architected framework as well as the cloud architecture. AWS Cloud Shared Responsible Models. AWS Cloud Shared Responsible Model. Shared Responsible Model of Customer and AWS responsibilities. The customer responsibility for this particular model is majorly security in the cloud. So the shared responsibility model, the first option is related to the security in the cloud. This includes customer data, platform applications, identity and access management, operating system, network and firewall configurations. So here shared responsibility model of a customer and AWS responsibilities we are going to discuss here. In this particular concept, the customer is the responsible person for the security in the cloud. So the security in the cloud with respect to the customer, which includes customer data, platform, application, identity, and access management, operating system, network, as well as firewall configurations. Next comes to the client side data encryption and data integration, authentication. These are the major concepts related to the client side related to the customer. That is authentication. Only the authorized authenticated person can use this particular cloud model, which provides the data encryption and data integrity for the sake of the security towards the client side. Next comes to the server side encryption. This related to the server side encryption of the file system and data where networking traffic protection is there, which includes encryption, integrity and identity. Next comes to the AWS which is responsible for security of the cloud. This includes AWS Foundation, service of compute, storage, database and networking, and the AWS global infrastructure, which includes regions, availability zones, then edge locations. The security and compliance or shared responsibility between AWS and other customers. So there is a provision of sharing the responsibilities with respect to the security. That is, AWS operates, manages and controls security of the cloud. This responsibility includes securing the components from the host operating system and virtualization layer to the physical security of the facilities where services will operate. Next, AWS is responsible for protecting the global infrastructure, which includes all the services that are offered in AWS cloud. Next comes to the cloud infrastructure, which is composed of hardware, software, networking, and that facilitates to run AWS cloud services. Here in security, we are also going to see identity and access management, which is known as IAM service. This service will divide the user as the root user as well as the AM user. Root user has the full powers to create AM users. AM users are the restricted users. As per the restrictions provided, they are authorized to use the services, and the bill will be provided to the root user, and the AM user will have the credentials to use the services only as per the provided by the root user. The AM user will use the configured fine-grained access control to the AWS resources. You can also use the AM user to follow security best practices, granting unique security credentials to the users and groups. So the root user will grant the security credentials to the users as well as to the groups, so that the best use of security will be done through the AM user. These credentials specify which AWS service API and resources should be used, and the user and the groups can be accessed. Next comes to the IAM, which is meant for the security to secure by default, where the users does not have an access to the all AWS resources until permissions are granted by the root user. Until the permissions are explicitly granted, IAM is integrated into most AWS services. Next comes to the where you can define access controls from one place in the AWS access management console, and they will take effect throughout your cloud environment, AWS environment. You can also use IAM to grant your employees and applications access to console to the AWS service APIs by using the explicitly in existing the identity systems. So this is all about the AM user, which supports the security, whereas based on the root user provision of the credentials and the authorization to use the services, the AM user will use. Then AWS supports the federation from corporate systems such as Microsoft Active Directory and standards based on the identity managers or identity providers. Next, after this, we are going to discuss regarding multi-factor authentication. Not only the username and password, even AM will support the multi-factor authentication. That means they will get the unique code to their mobiles or emails. So IAM also supports multi-factor authentication, that is MFA, which is enabled and IAM user attempts to log into it. They will be prompted for an authentication code. Next comes to the authentication code is delivered to the IAM device, that is IAM provided MFA, multi-factor authentication device, such as hardware virtual device or mobile phone or a provided email address, For example, Google Authenticator will provide the virtual MFA device to run the application on your smartphone. Then comes to the AWS responsibility for the security, then AWS foundation services. The different AWS foundation services includes compute, storage, database and networking. Then it will be related to the AWS global infrastructure that interrelates with regions, availability zones and edge locations. So this is all about the AWS shared responsibility model, which consists of the customer related as well as related to the AWS responsibility for the security and customer responsibility for the security in the cloud. When we discuss related to the customer responsibility for the cloud in the AWS related security, that is customer data, platform, application, integrity and access management, that is IAM service till now which we discussed. Then comes to the operating system, network and firewall configuration. Here the customer related responsibility for security model includes client side data encryption and data integrity authentication, whereas the server side encryption includes file system and or of data. Next comes to the networking traffic protection, which includes the encryption, identity and integrity. Then comes to the AWS responsible for security of the cloud. The AWS responsible for the security for the cloud includes AWS for foundation service, which is part of communicate, storage, database and networking. Then AWS global infrastructure, which includes regions, availability zones and data locations. Then comes to the customer responsibility related to the security in the cloud. So the customer data is the major concept here. To protect the data, the security plays a major role. The customer responsibilities are Amazon Elastic Cloud Compute, which is considered as EC2, which provides the instances where based on the instances the customer can utilize these instances to keep his data, and on these instances he can design the operating systems, he can design the storage, he can design the databases. Then comes to the applications that will be provided on the EC2 instance. It includes the patching, maintenance and other concepts related to the applications. Even the AMP services is based for the security, for the multi-factor authentication, passwords, rule-based access, etc. And here it is also secures the group through the security group configuration. So these all are the different factors related to the AMP. Then operating system, network and firewall configuration will also protect the customer's data. Customer's responsibility is to create the security groups, to maintain the network and to maintain the firewall configuration. Then comes to the client side encryption and the data integrity authentication. Then comes to the server side, it is the encryption, that is file system or the data. Then comes to the network traffic, which is meant for the protection, encryption, integrity and identity. This is all about the customer configuration, configurable customer responsibility towards the security in the cloud. Then we are going to discuss the services characteristics and security responsibility. So the services characteristics and security responsibility is related to the infrastructure as a service, platform as a service and software as a service. These different types of services will have the characteristics related to the security. First, we are going to discuss related to the infrastructure as a service. The example of the services that are managed by the customer or Amazon EC2, Amazon Elastic Compute Block Storage, then Amazon Virtual Private Cloud, that is Amazon VPC, then Amazon Elastic Block Storage. These are the three different services which are interrelated for the sake of the security responsibility. The customer has more flexibility over the configuring, networking and storage settings. Then customer is responsible for managing more aspects of the security. Customer is responsible for configuring the access control. So the responsibilities of a customer related to the service characteristics of infrastructure as a service related to the security responsibility are discussed here. Next, we are going to discuss related to the platform as a service. The different services provided by the AWS related to the service characteristics and security responsibility or AWS Lambda, which is interrelated to the platform as a service, and then comes to the Amazon relational database, that is Amazon ODS, AWS Beanstalk. These are the three different services which we did as an example for the platform as a service, which provides the service characteristics and security responsibility. The customer does not need to manage the underlying infrastructures. The AWS provides the operating system, data patching, firewall configuration and disaster recovery. Then comes to the customer, which focus on managing code or data. Then comes to the next service that is related to the AWS is software as a service. So the customer responsibilities and security responsibility that is related to the software as a service is AWS, that is about the AWS Trusted Advisor, AWS Shield, then AWS Shame. So here the software is services which provides the security or responsible for the security to configure by the user. Is software is centrally hosted and it is licensed on the subscription as pay as you use model, as go pay as you go basis model, that is about the subscription model, or pay as you use go model. These services are typically accessed via web browsers, mobile apps, application programs, interface APIs, application program interfaces. Then comes to the customers do not need to manage infrastructure that support this particular service. This is related, this is so user friendly to configure the software as a security responsibilities, the security with respect to the software as a service. Then comes to the AMP, which we discussed previously, that is about the AWS identity and access management. The use of this particular is to manage the resources where the root user is the owner and the AMP user is the person who uses the AWS based on the credentials provided by the owner and based on the authorization situations or authorization, how far he is authorized, based on it he is going to work. So the use IAM to manage access to AWS resources, that is AWS resource is an identity entity in an AWS account that you can work with, that is example resources or an Amazon EC2 instance or an Amazon S3 bucket. Then this is an example to control and can terminate Amazon EC2 instances. So here Amazon AWS identity and access management not only relates to the manage access to the AWS resource, it will even control who can terminate can terminate the Amazon EC2 instances, where it will be defined as the fine-grained access rights, who can access these particular resources, and can even responsibility can be given by accessed, what can the user can do the resources and how the resources can be accessed. Then AM is not a AM is a no cost AWS account feature. So no cost, among the no cost features, the AM is also one. AM means AWS identity and access management. Then comes to the AM, what does AM will do, how it is related to the security. So AM controls individual or group access of your AWS resources. It will integrate what other users of AWS services will do, other services of AWS will do, and it will integrate all the AWS services as per the requirement, and it will provides a federated identity management. It will support multi-factor authentication, and it will allows the regular permissions, and it will even can restrict the permissions based on the root user provisions. Then comes to the AM. First is the AM user. Different components in related to the AM. The first one is the AM user. A person or an application that authenticate with an AWS account is the AM user, and a group of users are granted identical authentication then considered as a AM group. Example, clerks in the particular company considered as a AM group clerks. Managers in the particular company considered as a AM group managers. So there is a much authorization or credential differences between the AMU's clerks and AMU's managers. Then comes to AM policy. This is the document that defines which resources can be accessed at what level of an access to the each resource. Then comes to the user, that is the AM rule, which is useful mechanism to grant a set of permissions for making AWS service requests. So these are all the different concepts in AWS identity and access management. So here the other terminology related to the AWS access identity and access management or AM resource, where the user group, role, policy and identity provider objects stored in IAM, AM entity, where AM resource objects that are used in AWS for authentication. Then AM identity, where AM resources objects that can authorized in policies to perform actors and access resources, that is user group or role. Then comes to the principal, that person or application that can sign in and make requests of the AWS. Then these all as part of the AWS authentication and authorization related to the AM user as well as the root user. There will be the root user will provide the authorization and as well as the authentication to the AM users. Now, what do you mean by authorization and what do you mean by authentication, that we are going to discuss here. So here AM user will request for the authentication to the root user, and also he will request for the authorization to the root user. Based on these credentials, the AM user will work. Then who is requesting access to AWS account and what are the resources he can use can be considered by using these particular authentications, credentials of authentication and authorization, and it will determine whether you are allowed or to deny the request, that is authorization, whether it is important to establish the identity of the requester through the credentials, the username and passwords or the primary credentials, and multi-factor authentication or the other credentials.